Hey everyone, today we'll be doing problem number 18 of homework set number 1. My name is Mark Santa Cruz and welcome to my pencast. So, a sound source is located somewhere along the x-axis. Experiments show that the same wavefront simultaneously reaches listeners at x equals -7 meters and x equals 3 meters. Part 8 asks, what is the x-coordinate of the source? So, based on the information we were given, we know that both listeners are on the x-axis. More importantly, we know the locations of the two listeners. So we have one listener at x equals -7 and one listener at x equals 3. And we want to make sure to always label our graphs and make sure to include our units in our calculations. So just wanted to bring that up. But anyways, we have our x-axis here in meters, and we have the location of the two listeners. So if we want to find the x-coordinate of the source, and we know that both listeners are hearing this, or they're getting hit by this wavefront simultaneously, then what we can do is calculate the midpoint from these two locations. So we have -7 meters plus 3 meters. We will divide that by 2 and get the x-coordinate of our source, which would be -2.0 meters, meaning that the sound source location will be somewhere around here. So this would be -2, -1, 0. I'm just going to finish labeling this graph real quick. Okay, so we have our source and our two listeners. Part B is asking that a third listener is positioned along the positive y-axis. What is her y-coordinate if the same wavefront reaches her at the same instant it does the first two listeners? So we know that she's in the positive y-axis area, so we know that she's somewhere in here. So here's our y-axis. And it tells us that all three listeners are hearing this wave or getting hit by this wave at the same time. So what we can do is draw this semicircle here, because if at this moment in time this listener is getting hit by the wave, so is our third listener, and so is this other listener. And from here, what we can do is find the y-coordinate. So we have this distance here, which happens to be 2 meters. So what I'm going to do is just redraw this triangle here. So we have this being 2 meters, and we know that this is 5 meters. And the reason is that in this semicircle, the distance from here to here, also known as the radius, is 5 meters. And if we know that this is 5 meters, our radius, then this should also be 5 meters as well. And what we want to do from here now is just some simple calculations to get us this distance that we want. So we have 2 meters squared. Let me clean that up real quick. 2 meters squared plus our distance of y, we'll call it y, so it's y squared equals our distance of 5 meters squared. And some simple calculations will give you the distance that we want, or our y position. So we have it y equals the square root of 21 meters. And if we punch that into our calculator, we are given our y-coordinate, which is 4.58 meters. And one way to just kind of check our work is, well, if this is our hypotenuse, and the hypotenuse is the longest side on this right triangle here, then our y, which is 4.58 meters, should be smaller than 5, and that checks out. And well, according to our answer key, looks like we're correct. And apart from that, I'd like to thank you for listening to my pencast, and I hope you have a wonderful day.